Hi everyone, welcome back. Today we're going to be talking about trig integrals, but this time we'll be talking about only the ones with tangent and secant in them. So just like last time with sine and cosine, these are going to be integrals that are formed by some power of tangent times some power of secant, and it's going to involve a whole bunch of u substitution, sometimes differentiation or integration by parts, although we won't really cover that here. I do want to make one key distinction between the sines and cosines versus secant and tangent. It's the derivatives. So if you differentiate tangent and if you differentiate secant, you get second order, this is secant and a tangent multiplied, or you get secant squared. You get second order trig functions, whereas if you do just sine or cosine, you go between, you add a negative, but you go between them and you don't add a power. So if I differentiate sine, I don't get cosine squared, I just get cosine, right? So this is going to make the process by which we do these integrals a bit different, because instead of looking out for single powers of sines and cosines, we have to be looking out for second powers of secants and secants times tangents. All right, so let's go ahead and do an example. Let's start with the integral of tangent square root of x secant to the fourth of x dx. This one's going to be really simple because I want to get us back in the groove of how we process these questions. But what I'm going to do is I'm going to pull a second power of secant to the end, because I notice that I have tangents involved, and I also have the second power of secant here, which if I move to the back, it leaves a second power of secant for me to transform into a tangent using this identity. So there's a lot that I just said. Let's go ahead and actually do it. This is equal to the integral of tangent square root of x, secant square root of x, and then secant square root of x dx. Right, so right here I have a derivative of tangent. I also have tangent sitting up here. So it looks like this is going to be a very nice u substitution. I let u is equal to tangent of x. This becomes du here. And so if I rewrite this integral, I get u squared secant squared of x du. And then like last time, it looks like we're in trouble because I have an x involved in a du integral. But what we can do is we can go up here and we can use this identity here to transform secant into tangent. So in particular, this becomes u squared. Secant squared of x is 1 plus tangent squared of x. This becomes 1 plus u squared du. You can FOIL that out and actually do the integral, and that will give you a simple third tangent cubed plus a fifth tangent to the fifth power plus c. Okay, so this is pretty typical. This looks a lot like the one we did, for example, A in the last video, but they can get a lot more complicated. So let's go on to the second example here. Let's do the integral of tangent cubed all on its own. So what we notice here is that we don't really have any secants going on. So if I want to use some sort of u substitution off the bat, notice that my derivatives of either tangent or secant have a secant in them. So this is secant cubed, this is secant times tangent. I don't have one of those in my integrals, so what I need to do is I need to make one. So I'm going to pull a tangent to the back. Again, a very unnecessary step, but I like to do it just to keep myself clear. And what I'm going to do is I'm going to use that identity we just said to rewrite tangent squared as secant squared minus 1. So this will be equal to secant squared of x minus 1 times tangent of x dx. And I can FOIL that out. And I get secant squared of x tangent of x dx as one integral. And I'm going to subtract off of that tangent of x dx. So, it doesn't look like we can do too much with this back integral. Lucky for us, this is, what's called an elementary integral. Someone knows the definition of it. And so this will actually give us the natural log of secant plus c. So that's what just the integral of tangent will give us. It's this beast up front we have to take care of. So what we can do then is we can keep a power of secant, because I recognize that I have a tangent here. I have a secant I can pull away from this and stay, or keep a secant outside of the du to make my u. that was complicated, sorry. Secant of x, tangent of x, dx, plus log secant plus c from that back integral. And what you notice here is I manufactured a u substitution out of this. So I have a u here is equal to secant of x. Whoops, I just wrote sex, whatever. Secant of x du. And then we simply have the integral of u du plus the other stuff. So this gives me 1/2 secant squared of x plus the natural log of the absolute value of secant of x plus c. I missed a minus sign along the way, so this integral, this was supposed to be minus this stuff here. So this integral without the minus sign is equal to positive natural log. So I add in this negative sign here that came from up here, and we're good to go. Cool, so this is our final answer here. It was a bit more complicated because we didn't have any secants right off the bat. We needed to get them, and we had to split our integral up into two different ones. Okay, so let's do one final example. Nothing too tricky going on here, but it's similar. So let's do just secant to the 4th power on its own. What we can do here is separate this out into a secant squared of x times the secant squared of x dx. Not necessary at all. But what we can do now is we can take this out, make this 1 plus tangent squared of x, and then we can get that variation that we need to make a u substitution, right? So now I have the integral of 1 plus tangent squared of x, secant squared of x dx. When I FOIL that out, I'll get the integral of secant squared of x on its own, and I'll get the integral of tangent squared of x, secant squared of x dx. Okay, so this first integral here, it looks scary, but this is literally just the integral will give you tangent, right? So the derivative of tangent is secant squared. So this one here gives us tangent of x plus c. And then this back one is a typical u substitution, right? So I have my derivative here, secant squared dx gives me du, so long as I make u equal to tangent of x. Okay, so this gives me then plus the integral u squared du, which we know how to do. So this gives me a 3rd tangent cubed of x plus tangent of x plus c as a final answer. Okay, so these are not that bad. It's just important to recognize that you're no longer searching for just individual powers of secant or tangent when you're looking for a derivative. You have to look for even powers. So in this case, even powers right off the bat are your best friend, whereas in the sine and cosine case, the odd numbers were your best friend. So hopefully this was a good review of trig integrals involving tangent